So hi everyone, today we're gonna solve trapping rainwater problem. So let's dive into the problem. So given n non-integer negative integer representing an elevation map where the width of each bar is 1. So the question has given us that the width of each bar is 1 and compute how much water it can trap after the rain. So the question says that when it rains, how much water will this block will be trapping, will they trap? So let's dive into. So here are the example by the Leetcode. So today we will gonna look for this example. This is quite long, so we'll be seeing the example too. So here is the example. So let's dive into the logic. So for trapping of water, what it requires, we need two boundaries, boundary 1, boundary 2. So here the water will be trapped, right? For the single block, the water will be spilling out. It won't trap the water. Okay, so the basic thing is that this is the basic thing, that it requires two boundary. And the second thing is that if the block is in the ascending order, the water might spill from here, or in the descending order, the water will be spilling here. So what we can conclude from here is that so I'm going to write here so the block should be greater than 2, and the block cannot be in ascending or descending order. Okay, so this is the basic thing. So from the example 2, so we're gonna take this height. Okay, so the height of first block is 2, 2, 0, 3, 2, 5. So if the water rains, if the rain falls here, or the water, from the first block, it will be spilling outside. The water won't get trapped. So for the second one, okay, if the water is filled here, so water is filled, so we need, as you can see in the diagram, this is the place the water is trapped. So now we need to find the water trapped between the blocks. So to find the water trap between the blocks, so we need to find, first of all, let's assume the height of the block is x. So I'm consider the height of the block is x and the water level to be w. So to find this, we can subtract height of the water level w minus x. So and if I multiply with that, let's calculate the water trap for the first block. So for the first block, the water level will be 0, as it's the first block, so the water level will be 0, and the height of the first block is 4 and the width is 1, as it's mentioned in the question. And so by computing this one, so 0 minus 4 into 1 will get -4. So for this question, we'll be considering the water level whose value is negative. Will be considering this as a 0. Water trapped will be 0 minus 4 into 1, as in question it's given that the width is 1, so here -4. So for this question, we're gonna take, if the water trap comes negative, we're gonna consider it as 0. If it's negative, we're gonna consider this as negative. And for second block, if we calculate how much we get for second block, water trapped will be 4 minus 2 into 1, so it will be 2. Here the water trap will be 2. So for this one, 4 for third block, it will be, the trap will be 4 minus 0 into 1 equal to 4. This one will be 4. Similarly for this one it will be 1. For this one it will be 1. So it will be, for fourth block it will be, 4 minus 2 into 1, it will be 2. So it will be 2. The sum comes 9. So it's same output here. So we can conclude from here is that logic. So from 2 we can say that water trapped will be water level minus HIGS, the height of bar, into width. So we found that water trapped. So now we need to find water level. So how can we find water level? So for water level we're gonna find, so let's see this diagram over here. Okay, so for water level, so we're gonna take is that, so from here we're gonna take this minimum of left and right. We're gonna take maximum of left and maximum of right. So basically what we're gonna do is that, so let me take this example. So let's take the example of this bar. So let's take this first bar as a height of 4, and let's take this bar, its height is 6. So if the water falls here, what will be the maximum, like what will be, how much the water will be trapped? So it will be till 4 it will be trapped. If it's above 4, then it will be spilled, it will be flown. It's like a, think this as a valley or a pocket. Okay, think this as a valley or a pocket to store water. So let's take another example. This bar is 4, this bar is 5, this bar is 6. So how much the water will be trapped over here? How much water will be trapped? It will be trapped till the 5th. So here is the logic to find the water level. So what we're going to do is that we will be taking the water level, we will be taking the maximum left side, from this left side, like the 4 and 2, the maximum will be 4. So for 4 and 0, the maximum will be 4. So for 4 and 3, the maximum will be 4. So for 4 and 2, the maximum will be 4. For 4 and 5, the maximum will be 5. So we will be taking the maximum of left and maximum of right, and we will take this both minimum. We will take this both minimum. So after that, so we're ready with this our water level. How to find our water level? So the question arises, how can we find the maximum left and maximum right? So here the logic. So I'll teach the logic here. So for the maximum left and maximum right. So the for the right we will be taking, for the left we will be taking left hand side. So the first element will be same, because this will be spilled, the water will be spilled outside. So to find this maximum left and maximum right, we're gonna take help of auxiliary arrays, or we can say helper arrays. So yeah, so let me draw the arrays for left and arrays for, so 4 2 0 2 3 5. So this one's for left, this one's for right. So the first element will be same, so 4, and we will be comparing this 4 with this second element of the arrays. So we will be taking the maximum 4 comma 2. So which one is max? So 4. So we'll be taking another element, this we'll be iterating through this arrays, and we will be taking this 0. So 4 comma 0, which one is maximum? So 4. So we will be taking another, this one 4 comma 2, which one is 0? 4. So it will be 4. So 4 comma 2, 4 comma 3, we will be taking 4. For this one 4 comma 5, we'll be taking 5. Yeah, for this right one, what we're going to do is that we'll be starting from last. So from n-1 will be starting, so the last element will be same, so 5. So we'll be comparing 5 comma 3, so 5. So for this one 5 comma 2, 5, 5 comma 0, 5, 5 comma 2, 5. So 5 comma 4, 5. So these are the auxiliaries arrays. So after finding max left and max right, we'll be taking the minimum of this both to find the water level. So here we are done with logic, and so now we will implement our logic by using Java. So here, so we'll start with the int n equal to length of height, HEIGST, height dot length, length. So now we'll find the maximum left. So for that we need to create an arrays of left. So here I'll name it the left max equal to new integer, size will be till n. So the first element will be the same as the first element of height. So left max 0, as arrays start with 0 index, so the first element will be same as height, HEIGST, height equal to 0. So the left max is an auxiliary array, okay, or the helper array, which I explained you previously. So the first element is filled. Now I need to fill the remaining spaces. So to fill the remaining spaces I need to use for loop. So int I equal to 0. So no, I equal to 1, as I filled the first index, so our filling starts from the second element, so that's why I is equal to 1. So I less than n. So I plus plus, we're incrementing. So to fill I left max I will be maths dot max math dot max height I comma left max I minus 1 till the last. We are taking the maximum of height and the maximum left max. Okay, so here it is. So where from here to here will find our maximum left. So similarly we need to find for right max. So I need to create an right max array. Array is right max. Okay, new integer n, same as previous. So the filling will, for the right max, the filling will start from the end. So I register right max equal to right max n minus 1 will be height height n minus 1. So the last element is done. So now we need to fill the remaining elements. So I need to run the for loop. So int I is equal to n minus 2. This will be the second last element, n minus 2. So I will be greater than or equal to 0. And I minus we're decrementing. So I is the right max I equal to maths dot max. So height is the height I comma is the right max I plus 1. As this move forward from back to forward, so it will be I plus 1. So here it is. So now we need to find the trapped water. Int trapp trap water equal to 0. I have initialized this trap water with 0. So now I need to find trap water. So I'll be using the for loop equal to 1 I less than n I plus plus. So int water level, to find water level we need to find the minimum of this right max and left max. So minimum will be left max square bracket I comma right max I. So this one's, so for trapped water trapped water plus is equal to trapped water plus is equal to water level minus height. Height. So I'll return the trap water. Trap water. So yeah. Let's run it and check it. Is it working? Or yeah, it's done.